Okay, last time we started solving inequalities, and we have noticed that inequalities may have more than one solution, actually a bunch of dots, and they actually are located on a piece of line, and we can graph them. We can put them in set builder notation. By the way, this is what we call a set builder notation. This is the regular inequality, but when you put two curly set parentheses, x with a vertical bar, we call it set builder notation, okay? Because in the next question, we are going to make this notation. And then the other way to show the solution is interval notation. So there are three notations, three ways we can demonstrate the solution: graph, set builder, and interval. This is what's needed in our first problem. It says first solve this. Solve means when I need to replace the word solve by another one, it means isolate. We got to isolate the W. I think we've done this question last time, but I just flipped the numbers, so it's kind of new one. So let's remember how we do this again. We need to isolate the W. It has -7 in front and 5. I need to get to the both numbers. Which one is first? 5. So I will take -5 off from both sides. So this way I can cancel this and get -7W less 75. Right? Isn't 82 minus 5 is 75? Not. I don't think so. 77, right? Alright, it's 77. Now let's divide both sides by -7 because we don't want to have anything besides W. So I divide both sides by 7, -7. And finally, W is there, which is, what is 77 over 7? How many times 7 goes into 77? -11. Alright, mistake. I did the same mistake from last time. We need to flip the sign. Yes. Why? Why do we need to? Is it because of division? It's because the negative. Division is fine. Usually you don't flip the sign by dividing a number with a number, but the negative sign is the real cause of flipping the sign. So I need to change this sign to this way. Okay? Green one is the correct. Alright, is this the set builder notation done? No. This is just the solution in inequality form. To make it in set builder, all you need is get these symbols first and declare what your variable is in the declaration page. What is your variable you're dealing with here? W. And put a vertical bar. Now put your solution right here, which is W greater than, I wish I could have it, but W greater than -11. Okay? That's it. This is step 1. Okay. That's part 1. Let's get to the part 2, and then we put all together the answers in the homework. How do you make this inequality into an interval now? So I'm going to get first a line. I'm going to draw a line. You may say, why? They're asking for an interval. Why are you drawing a line? Because I want to see the solution with my eyes, interpret it, understand it, then convert it into interval. I need to first translate this into a graph. But before translating into graph, I want to translate this into a sentence. What kind of sentence? Just turn this into a sentence. What does this say? W means numbers. All numbers. Okay, what is the rest? What does this mean?
Greater than.
Greater than. Greater than what? Minus 11. Okay, so I need to demonstrate here all the numbers greater than minus 11. I need to start with minus 11 and count everybody numbers after that. So where is minus 11? If 0 is in the middle, minus 11 should be somewhere on the left. Let's mark it here. And numbers greater than minus 11 is, where are they located? To the left, right? Here? No, this is minus 12, minus 13, 14, all smaller. Yeah, they are big in digits, but since they are negative, they are actually smaller. So we need to cancel that and go this way. Minus 10, 0, 1, 2, 10, 100. How far can I go? Unlimited. So we put the arrow there. And next, I need to decide whether to include my minus 11 into red numbers into this set or not. Shall we include minus 11? If you are going to exclude it, not include, you need to put the parentheses there. Okay? Now we are ready to change this into interval. How? It's there. Do you see a parenthesis here and a number? On the left, far left, that's what the first piece of your interval notation is. So my interval starts with this parenthesis and minus 11. And usually ends with another parenthesis or bracket, but I have nothing on that end. If I have nothing, what does it then? It's infinity. So this looks like more like a bracket. Shall we put a bracket though? Or parentheses?
It's always parentheses.
It's always parentheses with infinities, because infinity is not a real number you can fit into an interval. It's something huge, it won't fit. You cannot include it. It's always excluded as default. Minus infinity, minus 11 infinity is the answer of part 2. Okay? We already graphed the solution over there. So our problem 1 is over. Right? Any comments? Okay, I'll show you here. Okay, set builder, you first make this set notation, put your variable W, and then this or, and what was the solution again? W less than? Greater than. You can make greater than symbol with a keyboard or using this button on the toolbar. Minus 11, right? Check. Good. Solution in interval notation was minus 11 to infinity. Alright? And to graph, you need to first choose this button and color starting with minus 11, point first spot minus 11 is here. We need to color towards infinity, right? So greater than minus 11, this side. Any questions? Have we got full credit on this one? Now we're going for next one. Similar question, isn't it? Well, something is quite different. Yeah, they ask pretty much the same thing. Set builder, interval, graph. Same setup. However, what's the deal? What do you have? What do you see all over the place?
Fractions.
Fractions, yes. Denominators. We hate denominators, don't we? I mean, I can add and subtract 5 and 3, but not 1 over 5 and 1 over 3 because there's something called common denominators. I need to get common denominators, then I can subtract, right? So that's why denominators are always a hassle. We need to get rid of them. I mean, some people like to get common denominators and stuff, but I rather not go into that. It's correct, you can do that. I instead multiply things on the left and right with something big enough that can wipe off all my troubles. What? Denominators. They are troubles, right? So I want you to multiply left and right with a number big enough that can kill 5, 3, and 15 all. What is that number? You need to be economical. Don't go overboard and say 1 million. Yeah, I know 1 million. No, 1 million is not going to kill 3. But it's not divisible by 3. You can say 300. 300 is divisible by 5. It's good. It will wipe off 5. It will wipe off 3, 15. But it's going to make everything huge, 300, right? So let's go smallest possible number. And somebody said it already. 15. It's actually this one. Look, when you put 15 here, 15 and 5 cancels. And I put 15 here, 15 and 3 cancels. Cancels means it's wiping off your troubles, right? And 15 and 15 canceling too. 15 is what we are going to put to both sides. Okay, here's what I'm doing. You can do this. Okay, this is a little long version. Put 15 to the left and 15 to the right, like that, with parentheses. And then you need to put 15 to each, in front of each fraction, like distribution. You're multiplying the first one by 15 and second one by 15. Or, you like it? Is it okay? Or you can go fast forward and you can do immediately this. I'm going here. Put 15 to in front of each and every item quickly. You can skip this first step and show me directly 15 times the first one and minus 15 times the second one. Make sense? So you can immediately jump to this step and start here. And less than, what do we have? Can I cancel these quickly? And we have only negative t, right? You agree? Any questions? Confused? You understand why I picked 15, right? You could have picked 30, it works, but it's too big. You're gonna deal with big numbers. Okay, next, most people think, oh, I need to multiply this 15 with top, this 15 with top. Yeah, it's okay, you can multiply them, but what was the reason why we multiply 15? To cancel the denominators. So don't multiply yet. First, cancel the denominators. And I'm going to do that. 15 and 5 cancels, right? But there is still something left over in 15, which is, what is 15 over 5? 3. 15 divided by 3 is 5. Then you have number now, multiply with leftover numerator, or whatever leftover is in this fraction. It's a numerator only. 5 times this, 3 times that, and this remains like that. Okay? Alright, look how I'm multiplying this thing. Okay. I will go ahead and multiply 3 times 3. What is 3 times 3? Everybody knows that, right? 9 plus t. Okay? And then I have minus 5. Don't forget, we have a minus in front. This is a minus 5. You multiply. Minus 5t. I was expecting that. Yeah? What's that again?
13.
Yeah, this is wrong multiplication. Basically, there is a secret parenthesis here, and this 3 needs to be distributed over this parenthesis. You not only multiply the first one, the second guy as well. So when you don't multiply like I did here, it's a mistake. It's supposed to be now 3t. Okay? And this one too. This minus 5, there's a secret parenthesis here, it needs to be distributed over. And 5t minus 5t, and minus 5 times positive 3, which is negative 15. Okay, are we good so far? Look, all of our issues are gone. What was our issue? Denominators. Do you see any more denominators? Any more of denominators? No. Perfect, smooth problem now. You can get to the result. All you need to do is bring two the t's together, numbers to the other side, and isolate t. Solve for t. But I have some simple calculations like 9 and 15. What is 9 and negative 15 make? These two? They make what? Negative 6. Alright, 3t and minus 2t make negative 2t. Negative 2t minus 6 less minus t. Okay? Okay? Alright, I need t's together. I have some t's on the left, some other on the right. We need to move one of them to the other side. Which one you prefer? You want to move this one? So what do you do?
Plus 2t.
You can add plus 2t to both sides. It's going to wipe this one off and populate something else here. First grade. Or you could add plus t to both sides and get t's on the left. However, I like the first option better. If I remove this one to this side, I still have negative t's. I don't like dealing with negative numbers. So first one is a better idea. Let's put plus 2t both sides. 2t here and 2t there. Okay? And gone. We have, I'm going to continue here. We have only minus 6 left on the left side. And on the right, we have t. And that's our solution already. Why? Why did I stop? What is our goal? Our goal was to isolate. And do you see anything else besides t on this side? It's already been isolated, so we stop. This is our solution. They want it in set builder, so this is all you gotta do. T bar and this thing moving in here. Okay? This is part 1. Part 2, they want the interval notation, but guess what? I will do part 3 first, then go back to part 2, easier. If I see things clearly graphed, I can do the interval next. So I will first graph this thing, then make the interval notation, alright? Let's graph it. Translate this into sentence. Negative 6 less than t, or flip it, t is greater than minus 6. You can read from left to right or right to left. Left to right, it reads as negative 6 is less than t's, all numbers. Doesn't much make sense, so read from the right side. Read from the variable side all the time. T is more than minus 6. Numbers, pick all the numbers more than minus 6. Alright, so I need to mark minus 6 and color everything more. Okay? And now, what do I put on this side? This guy. Parentheses. Why? No equal sign, because of no equal sign. Alright? Now let's make the interval notation. Anyone? Can you make it? Look, you just need to read start and end. Where do we start? What number do we start with?
-6.
Negative 6. And in negative 6 we have a parenthesis. And what is the end? Infinity. Okay? Make sense? Alright, let's try this in. I'll just do the first one. That's, I think, enough. This is maybe the most difficult part. Because negative 6 less than t. Okay. 6. Come on. Infinity. Check. And alright, I messed up, so it's done. If you want to delete something, hit reset button. Okay. What is next? We're going to start compound inequalities. Well, where do they show up? Compound means actually more than one inequalities. We will deal with two inequalities actually, two in the rest of the session. But those two inequalities sometimes connected by the word and sometimes connected by the word or. Like normal glucose range in humans should be is either more than or equal to 70 or less than 100. That means more than 70, less than 100 is between 70 and 100, right? If you have less than 70 or more than 100, there is something wrong with you, right? It's abnormal. So compound inequalities happen everywhere, all right? So we may need to solve them, get them isolated just like we did earlier, all right? So basically, you just solve each individual inequalities like we did in the first two questions. And then, using the meaning of and or, we need to combine those solutions, compound those solutions. That part is a little bit tricky. All right, I'll show you on the example problem next. There are two questions here. We will do part A first, okay? All right, read the question. It says, solve the compound inequality. The rest is just, once you get to the solution, we graph and change it into interval notation. Regular steps. Solving is the main issue. Okay? So, This is not our concern right now, okay? Don't be confused by this. Part 8. There are two inequalities here. I will take each one and solve it. Why don't we solve first one right here? T minus 2. This is so easy to solve. Okay? You just need to get T by all by itself. This T must stay, minus 2 must go. What do I do? Add 2. Add 2 to both sides. We are all set. Okay? Alright. Gun, T is greater than 6 is the first half solution. Half the problem solution is here. Let's get to the other one. Okay, handle it here. 3/5 of T greater or equal 6. Isolate T. I need to get rid of T. It has two numbers in front. Actually, it's one number, a fraction, single number, but it has two pieces, top and bottom. How do you cancel that 3/5? 3
times 5.
We can first get rid of the denominator by times 5. Good, that works. I will clear this one. Alright, what do I do with 3 then? Divide by 3. So you can actually do both moves in one step. Why don't you multiply it by 5/3 then if you're going to divide it later, right? So kinda, if you have a fractional coefficient, you flip it so it can cancel everything. You flip and multiply both sides. Okay? And this will give us only 2, and 2 times 5, which is 10. Correct? T is, let me write the final result. T is more or equal than 10. Smart. Two solutions. Are we good? Two solutions. All right, let's put this into some context. You have either more than 6 apples or more than 10 or equal to 10 apples. That's what the situation is. We are going to now combine this by mathematically. Okay? Alright, so what do I do is I graph them. I graph both of them. I will graph this one on the top. This top one is for this guy. And this bottom one, you need to make sure you graph them on the same, align them on the same part of the paper, right underneath. Because we are going to compare them. Let's first graph this. Let's change it into a sentence first. All numbers either equal or more. You need to start with 10 and count forward. So where is that? If this is 0, 10 is here or more. Alright, shall we include 10 or exclude 10? Include, so I need a parenthesis there then? Bracket. Because more than 10 or equal to include it. Now let's graph this guy. This one here. Graph this one there. Alright, I'm going to pick another color for that. Let's go with blue. All numbers greater than 6. So I start with 6. Where is 6? 0 here, 10 there. 6 is about somewhere here. Okay? You see, I'm not putting 6 here. Watch for the top one. They need to be same scale, because I'm going to compare them. All right, 6 or more means I'm going towards east, right side. And do we put the bracket again? Some is a parenthesis. Okay, what's the meaning of or now? You're gonna take this crowd, these people, these numbers, and take the blue numbers, red and blue is going to, guess what? Or means union or unite. You're going to combine them. Alright, just think this as classrooms. These are the guys. There are millions of students here. This is student number 7, 8, 9. They are numbered, okay? This is student number 10. Your student ID 10, 11, 12, 13. These are 2 separate classes. English, math. Student ID 6 is not in this class though, it's excluded. But 6.1 is here, math, right? 11 is in the next room, English, okay? I call them, hey, come on, everybody, move in this class. English is here, red guys, so they need to move into this class, okay? So I'm going to move them in. They don't want to cooperate. At least some part of it came. Okay, just move down. Next one too. They moved in. What just happened? It looks like everybody in the next class were already signed up for this class. How is that possible? They were twins. I mean, I don't know. They have kind of cloned themselves. They were being in both classes at the same time. When they come into my class, oh my God, student ID number 10 was in my class as well because it's blue marked. 11 was also in my class. So what happened to union then? What is the union when I combine both classes? Because these red guys and blue guys are overlapping. They are the same people. You can't count them twice. So what is the union of these two groups? Anyone? Yeah. It's that entire blue group itself. Okay? Just think like this. This is my class, blue group is my class, but some part of those guys, at least this half, was also taking English class. I compared 2 lists, and I noticed that all those English class people are also in my class. When I united them, I still have my own class, blue class. Okay? So the solution is, in interval notation, still 6 to infinity. 6 to infinity. Or t is greater than 6. Does it make sense? Are you with me? Alright? So, in union, if one solution happens to be living inside another one, it just dissolves, it just disappears. And the bigger set survives is the answer, okay? Alright, what if I have another scenario? What if this wasn't 10? What if this was starting, it was starting like this, and this was, let's say, 3. What would be your answer? I modified it. It starts with 3 and ends here. 3 to there. What's the union now?
3 to 10.
It's 3 to 10. You are uniting. Now, this is my math people. English people came in here. There are new guys, but there are also overlapping people, both taking English and math. And there are people only taking math but not English, not in the red zone. When I unite all of them, invite them all here. It starts with 3, but it doesn't end in 10. It goes to infinity. The answer would be 3 to infinity then. Okay? Alright? So far we're done with this part A. In interval notation, 6 to infinity. What was the solution? 6 to infinity, right? Original one. We graphed it as well. The blue region. Now we're going to do the second half. Are we out of time? No, we still have time. Are you ready for part B?
Yeah.
Alright, I want you to notice the change. There is an AND connector now. 2 intervals, but they are connected, tied with the word AND. Okay? Let's see what kind of difference does it gonna make. I will solve each individual inequality again first. Let's go with this guy first. T minus 2. Oh, they're the same. We don't have to solve them. Come on. Yeah. They are the same. I didn't notice that. They are the same, so we can use those 2 solutions earlier. The top one, red, blue one. Red go from 10, right? It was 10, right? To infinity. And blue goes from 6 to infinity. Alright. What is the meaning of AND? Any ideas? It's not union anymore. It's intersection. In graphs, it means overlapping region. Okay? You are going to find what's overlapping between red and blue. Student number 10, 11, 12, 13, English takers, 6, 7, 8, 9, and then 10, 11, 12, 13. Those same people are math takers. Who are in both class? What is common terms between 2 sets? What's that? Yeah. It's 10, 11, 12. All these people are also in blue. Let's move it. It's a lot easier with the mouse. Let's move these guys. Here. Do you see what's overlapping between red and blue? This entire red area is overlapping with blue, but this is extra. This is not overlapping. So the solution will be this red area itself. This is our solution. This is the overlap. Okay? Make sense? Alright, there is one odd thing though. So how are you going to write your answer? This red area, but my suspicion is, what am I going to do with 10? Are we going to count this in green area or parentheses out of green area? Exclude or include in green? What do you think? You sure? Yes. Just answer this. Is 10 both a member of red and blue? Yes, it's in red, it's in blue, so yes, we include it. So overlapping area or the solution is, we start with 10 and go indefinitely. Okay? You make the bracket from the keyboard and infinity from the toolbar. Alright, let's graph that. Very good. Alright. Any questions? What does this mean? Do you see two inequalities here too? Do you? I see two greater than symbol. One here, one there. So this is a compound inequality as well. I never mentioned this. I mentioned two separate ones with and or connectors. This is a new one, but no, this is just a fancy way of saying this. You can actually break this into two pieces. Piece one, this is the first piece, and then this is the second piece. First piece can be extracted to the left side, and the second circle can be extracted to right side. And what do I put in between? You have two options, and or. Which one? Come on, give it a shot. You have 50-50 chance. And? Yes, the and is the right. So basically, this fancy notation, if you have two-sided inequality, one in the middle, left and right, middle, left and right, with these notations, you simply split them into two and put an end between. This is exactly the same work we did before. So you can solve this graph, solve this graph, and see what's overlapping between them. Okay? It works, but I don't recommend it. It's just too long that way. So instead, I just mentioned what this means. It's simply two inequalities compounded or combined into one new symbolized way. But I like this one better. Don't break it, don't spoil it. You're spoiling it, okay? It works, it's correct. You can get to that same answer longer though. So I want to get to the result directly in the given form. Don't break it. So I'm going to back up everything. This was just to explain what it is. I will go ahead and attack the question in the given format. Simply do what solve means. What is the meaning of solve? Isolate the variable. And it's in the middle. Isolate it in the middle. I need to get rid of -2. I need to get rid of 8. Which one is first? No. 8 is first. Always the one added to the variable or subtracted is first. This is multiplying. Always get the further one. This is kind of further than 2. Lose him. Kill him first. Okay? 8 is gone first by doing what? How do I get rid of it? -8? Where? Here? Where else? You need to put to the other side as well, right? On which side? Both. Not only to the right, but also to the left. All three parts, middle, left, and right, must get one -8. Okay? Now next, cancel. Cancel, add. So these are canceling. These are adding to 6 plus -8 is -2. -2x is the only thing in the middle. And what is happening here? They cancel? No, they add into -16. Right? Agree? Next. What is next? What do you feel like doing? Yeah, -2 is our next target. It's multiplying, so I need to use the opposite operation, which is division. And I will go ahead and divide by -2. And if you're not careful enough, you can mess up here. What? Where is the possible mistake? Flip the signs. We need to flip the signs. Yeah, why? Why again? The reason for this? Because of the negative. If you're operating with negatives, you need to flip the signs. Got it now, right? Okay, let's simplify this. What is 16 over 2? It's positive 8. -2 and -2 is positive 1. We're all there, right? 8 and x and 1. I missed something in equal sign. Yeah. Okay. Alright, we solved it. Let's graph it and put it in an interval form. Let's get our graph ready. What does this mean? I need to first understand so I can color it, right? So translate this. 8 is more than x. Now I need to always read from the x side. X is what than 8? Less than, yes. It's inside the fish mouth, so it's less. X is less than 8. Now let's read this side. Keep that in mind. X numbers are less than 8, but those numbers should be also, what does this mean? Fish greater or equal to 1. So you want to be more than 1, but less than 8. You get it? You're more than 1, less than 8, reflected into your picture. More than 1. So here is 1. Here is 1. I need to be more. Can I be more indefinitely? I need to be more than 1, but less than 8. So I need to stop at 8 then to become less. There you go. You have a piece of line. All right, here is the key part. if you have this double inequalities, it's always a limited piece of line. It doesn't go indefinitely. It starts and ends. Where does it start? It starts the small number, ends on the big number. This is a no-brainer again. See which one is small, which one is big. One is small, 8 is big. Mark them, color in between, that's it. Got it? Small, big, mark, color in between. Over. Well, you need to turn this into an interval though. Oh, no, I missed something. How about parentheses and brackets? Which one is parentheses, which one is bracket? I see a bracket at one equal sign. I see no equality. So it is parentheses. Bracket, parentheses, look. Your interval notation is here. Do you see it? Do you see the interval notation? Bracket 1, parentheses 8. Make it 1, 8. That's it. Okay? Make sense? Question is oh, I can't put it here because the questions I saw is different than this one. Every time I open a new homework, it flips the questions. So unfortunately, I can't try it, but you know, I'm always right? I don't make mistakes. So trust me. Okay. All right. I'll see you on Monday. We'll continue this. You too. Thank you, Dan.